Hello everyone. Today we are going to discuss a very important concept of vectors. You will see that if you have some knowledge of vectors, it will be very useful for you to understand so many things in physics. When we were doing motion in one dimension, then just adding positive and negative sign with the quantity was sufficient. But you will see that when we are talking about motion in 2 and 3 dimensions, then we need the knowledge of direction also. Okay, so when the object is moving in 2 and 3 dimensions, we need to specify the magnitude as well as the direction. So there are many quantities in physics which you study, for example temperature, time, mass, where you do not need the information of direction. But when you will study the quantities like velocity, acceleration, force, then you need to specify direction also along with that, with the magnitude. So we will see that when we learn about vectors, we can easily understand that how we will include the information about both the magnitude and direction. So let us start with the simplest quantity, which is displacement. So for example, if an object is moving from point A to B along this path, then what will be the displacement of this object? The shortest path from A to B. And if this object moves along different path and reaches the same point, then also the displacement is from A to B. This is the simplest vector which we define in order to understand vectors. Okay. So here the displacement vector, it does not depend upon which path you are taking. The shortest distance from A to B will be given by the displacement vector AB, where we denote this vector by putting an arrow over AB, or you can also just simply put a line. Okay, we can also write like this. And always an arrow and a vector is denoted by a line and an arrow at the head. These vectors, if they have the same magnitude of a vector means length of a vector. If two vectors having the same length and direction, they can be shifted from one point to another. So for example, if I have a vector like this, another vector with the same magnitude and direction will be like this. So this vector can be shifted anywhere. Okay, it will represent the same vector having the same magnitude and same direction. Now let us study few important properties of these vectors. We will see that how can we add these two vectors. Now suppose, so we will study addition of vectors geometrically. Suppose an object moves from A to B and then from B to C. Then the net displacement of this object from A to C will be denoted by this vector, which we'll call as the resultant vector of AB plus BC, and we will denote this as AB plus BC is equal to AC, and this AC is called resultant. Okay, so one important thing to understand here is that this AB plus BC is not the usual algebraic sum. This is a vector sum of two vectors AB plus BC, and this sum includes both the magnitude and the direction. Okay. Now when we add, so what we do in vector addition, when we have to add two vectors, then we will take first vector and the second vector's tail will be put on the head of the first vector, and then finally we will take the resultant from the initial position to the final position. Okay. Now let us see few properties of vector addition. Okay. So for example, if any vector, if any object moves from A to B and then moves back to B, back to A, then how much is the net displacement? The net displacement of this object is 0. So how do I write this in the form of vector? So for example, if AB I denote by vector A, and again from moving from B to A, if I denote by vector B, then how much is the net displacement? 0. And I can write this as A plus B is equal to 0 and vector A is equal to minus of vector B. So this is an important property to understand, that if I go from A to B, then it is represented by A, vector A, and if I come back to the same point and if I reverse the direction, that vector will be denoted by the negative of that vector. Okay. So this is one of the property of vector addition. Now we will see that we can check geometrically that the vector addition is commutative. How do we do that? So let me rub this. So we want to show second property, that vector addition is commutative. Okay. So let us take a vector A going from A to B, then I take another vector going from B to C, and then the resultant of these two vectors will be AC. So AB plus BC gives me the resultant vector AC. Now in order to show that this vector addition is commutative, what I will do, I can shift this vector BC from this position to this position. Okay. So let us denote this vector as A, B and C, and vector B I shift here. As I told you that the vector with the same magnitude and direction can be shifted. So vector B I have shifted here and it is denoted by dotted lines, and vector A I shift here. Okay, and then we can easily see that B plus A will again give you C vector. So this B, so here AB was A plus vector B is equal to C, and from this triangle what we will see, that if I go first from this point to this point, that is vector B, if I take vector B plus A will also give me C. This shows that vector addition is commutative. Okay, so this is a very important property. Next, we can also show that vector addition is associative. So in order to show this property, we will take three vectors. So let us go from point A to B. Let us denote this as by vector A, B to C, and C to D. Okay, this is okay. Now, if I do vector addition, vector AB, vector A plus vector B plus vector C, this will be equal to the resultant AD, and let us denote by this as vector D. Okay. Now, what I want to show, AB plus BC, if I club A plus B or AB plus BC, if I club together and then add to C, the resultant is D. And also I would like to show that this is equal to vector A plus vector B plus C. If I club B and C together, then also whether I get the same answer or not. So here I will check. When I take vector A plus vector B, the resultant is AC, and the result AC plus CD will give me the resultant D. Okay. So this is equal to, let us take this as okay, we can denote this by B prime. Okay, we can take anything. So A plus B gives you B prime plus C, and the result is vector D. Now let us take, I can use another color. First, let me take AB. We have to take B and C together. So vector B plus C, the resultant will be this. And let us denote this by C prime. Okay. So I want to show that vector A plus B plus C is C prime. C prime, and A plus C prime will again give you D. So geometrically we can easily show that whether I add these two vectors first and then add this vector, or if I add these two vectors first and then add this, the result will be same. This shows that the vector addition is associative. Okay. So what we have learned few very important properties of vector addition, that vectors can be geometrically added, the vector addition is commutative, vector addition is associative, and also if I reverse the direction of a vector, we get a minus sign. Okay. So now, in order to deal these vectors or add these vectors geometrically is tedious. So there is another way in which we can handle these vectors. So in order to add these vectors very easily, what we do, we resolve these vectors along the x-axis and y-axis. You might have already learned in the basic trigonometry that how do we define sine theta and cos theta. Okay. So that will help us to resolve a vector along x-axis and y-axis. So you might have learned, just a quick recap of what you have learned in trigonometry. So for example, if I have a vector OP and it makes an angle theta with x-axis and y-axis. Okay. Then if I take a projection of this OP vector on x-axis as OM and the projection of OP vector on y-axis as ON, then in trigonometry what we do, OM is defined, and also this is a unit circle. What do you mean by unit circle? OP vector, its length is 1 unit. So what we have defined, if we take a unit circle, the projection of OP vector on the x-axis is defined to be cos theta. Projection of OP on x-axis and projection of OP on y-axis, that is ON, is defined to be sine theta. Okay. This is how we define sine theta and cos theta in trigonometry. Now, if I make this circle r times, for example, instead of a unit circle, if I just enlarge all the sides by r, then how much will be the projection OM? OM will be r sine theta. Okay. R is the length. Now r is the radius of the circle or the length of the vector OP. So now length of OP vector is r. Then the projection will also become r times, and this is OM upon r is equal to sine theta and from equation 1, sorry, this is cos theta. And ON upon r will become sine theta. This is what you all have learnt, that cos theta is based upon hypotenuse. R, now this hypotenuse has become r. Okay. So if r, OP is a r vector, is a vector whose magnitude is r, then OM will be r cos theta and ON will be r sine theta. Okay. Or you can also say that cos theta is based upon hypotenuse and sine theta is perpendicular upon hypotenuse. So this is how we can resolve a vector along x-axis and along y-axis. Okay. So for example, if I have a vector now, vector A, which makes an angle theta with x-axis and y-axis, okay, then I can resolve this vector along x-axis and its component BAX, which will be equal to A. A will be the magnitude of vector A cos theta and its component along y, AY will be A sine theta. Okay. And if this is A cos theta and this is A sine theta, then how do I find the magnitude of a vector? So basically what we are doing, we are moving A cos theta in x direction and A sine theta in y direction. So the magnitude, I can find magnitude of vector A can be written as, by using Pythagoras theorem, how we can find AX square plus AY square. Okay. And if you use A square cos square theta plus A square sin square theta, you will get A, and A is the magnitude of vector A. Okay. So this is how we can find the magnitude of a vector A if AX is a component of vector A along x-axis and AY is a component of vector A along y-axis. Also we can find the angle, the direction of this vector, that how much angle it makes with the x-axis. This we can find by using tan theta. Tan theta will be equal to perpendicular upon base. Perpendicular is how much? That is the AY component of vector A. So it will be AY upon AX. Now I know everything about this vector. I know the magnitude of the vector and I know the direction of this vector, that what direction it has with respect to x-axis. Okay. So till now what we have seen, what we have learnt, that a vector can be resolved along x-axis and along y-axis. The component of a vector along x-axis is ax, which is a cos theta. A is the magnitude of vector A, and the component along the y-axis is ay, which is a sin theta. And we have also seen that how we can find the magnitude of this vector by using Pythagoras theorem, ay square plus ax square and the square root. Also we have seen that how we can find the direction of this vector by using tan theta. Now I want to write this vector in its component form. What do you mean? What do I mean by that? I want to write this vector by writing its components along x-axis and along y-axis. Now a cos theta and a sin theta represents just the magnitude. Okay, we also need to include the direction, and the direction of a cos theta and the direction of a sin theta. What do you mean by that? It means that I need to include the information that a cos theta is a component along x-axis and a sin theta is a component along y-axis. Then how do I introduce this information while representing any vector A? Okay, so for that I need to introduce another important concept which is called as unit vector. Okay, so what do we mean by unit vector? By the name itself, it is clear that it has something to do with unit. Okay, so it means, so what is the meaning of unit vector? A vector whose magnitude is 1 unit. Okay, so a unit vector is a vector whose magnitude is exactly 1 and it points in a particular direction. Okay, so now we have something which I can use to represent a direction. So what is special about this? Unit vector is a vector whose magnitude is 1 and it points in a particular direction. Conventionally, unit vector along x direction is represented by I cap. So what do we mean by I cap? I cap is a unit vector pointing in x direction whose magnitude is 1 unit and direction is x direction. Similarly, unit vector along y direction is represented by j cap and unit vector along z direction is represented by k cap. Okay, so I cap, j cap and k cap are the unit vectors whose magnitudes are 1 and the directions are, they point along the x direction, y direction and z direction respectively. Okay, now we can use this very nicely. Now I know that any vector A if it is in some arbitrary direction, it can be decomposed, it can be resolved along x direction where ax will be its component along x direction and ay is the component along y direction. Now I can use, and this ax and ay are just the numbers. Okay, so how can I represent vector A in terms of its components? By using unit vectors, we can write as vector A is equal to ax is a component in x direction, I cap is the direction along x direction plus ay j cap. This is how any vector, any arbitrary vector A can be represented in terms of its components. The components are along x direction and y direction. If this vector A has component along z direction also, then we can also add this component plus az k cap. So this proves to be very, very useful. Now what we can do, for example, if we have many arbitrary vectors in space and we want to add those vectors, what we can do? We can resolve all the vectors along x direction and along y direction. Then all the components along x direction can be added and all the components along y direction can be added. Okay. So for example, I'll give you one example. Okay. So let us take a vector A. Vector A 2i plus 3j. Okay. First thing, what will be the magnitude of this vector? So what is the meaning of this vector? That I have gone its component along x direction is 2. Okay. So here ax is 2, ay is 3. So we have gone 2 units in x direction, 3 units in y direction, and I reached here. The vector addition of these two will give me the resultant A. This vector is 2i plus 3j. Okay. Now, how do I find the magnitude? By using Pythagoras theorem. The magnitude of A will be square root of 2 square plus 3 square. Okay. So it will be 4 plus 9 root 13. Also I can find the direction of this vector by using tan theta. Tan theta is ay upon ax. Okay. These are just the numbers. This is purely number, this is a number. Okay. This is the magnitude of A. By using Pythagoras theorem, this is the direction of A, that how much angle it is making with x-axis. Now, if I want to add two vectors, how do I do that? For example, let us have vector A 2i cap plus 3j cap and vector B 3i cap plus 2j cap. I have to add these vectors, vector A plus vector B. Okay, I want to find this. This will be another vector, vector C. Okay, so how do I do that? These vectors I know it's written in the form of, in terms of its components. Okay, so vector A 2i, so 2 units here on x-axis and 3 units on y. So first I have moved here and then moved here. This is vector A. Okay, and how do I draw vector B? 3 units on x-axis and 2 units on y-axis. So this is vector B. Okay, so what I have to do? I have to add these two vectors. So if I add, so what we can do, if I know the vector in its component form, vector A plus vector B will be 2i plus 3j plus 3i plus 2j, and this is equal to these both the components are in the same direction, they can be added, 5i cap plus 5j cap. Okay. vector A plus vector B. This is vector C. So it will be where? Let us check on this axis. 3, 4, 5 and 5J. Okay. How can I show that this vector C, what I got here, is the resultant of A and B? So what you can do? You can just shift this vector B over C. Okay. So if I shift the vector, so this was the vector A, I can show you again, vector A, and then if I shift the vector B with its tail over the head of A and then find the resultant, this will give you C. So here it was 2 units, so 3 plus 2, 5, and then similarly it has moved 5 units on the y-axis. This is how we can easily do vector addition if I know a vector in its component form. Okay, so we can add the different components along the x-axis and we can add different components along y-axis. Okay, so this was and also let us do one more problem based on unit vector. Okay, now vector A is equal to, for example, vector A is 2i. Okay, what is the magnitude of this vector? This vector is along x-axis with magnitude 2 and direction I. The magnitude of A will be 2. And if I have to find a unit vector along A, then it will be how much? Unit vector is a vector whose magnitude is 1. So this vector has a magnitude 2. How do I make this vector of magnitude 1? By dividing by 2, right? So the unit vector is represented by cap. I, j and k are special unit vectors which are taken conventionally along x, y and z direction respectively. Now if I want to take a unit vector along A vector, so A cap will be a unit vector along vector A. Okay, so this vector, it should have magnitude 1 and direction same as the vector A. So direction is I cap, that is perfectly fine. Direction, it's along the x-axis, okay, but the magnitude is 2. So what should I do? I should divide this vector by 2 in order to get magnitude 1. So the unit vector along vector A will be I cap. More generally, I can write this as vector A upon magnitude of A. This is how a unit vector along any vector is represented. Okay, so let us take one more example. Let us take now vector A as 2i plus 3j. I want to find a unit vector along this vector. Okay, so what is the magnitude of this vector? First of all, let us find 2 2s are 4 plus 3 3s are 9 square root 13. Okay, and I want to find a unit vector along vector A. So in order to make the magnitude of this vector 1, what should I do? I should divide this vector by its magnitude. Okay, so the unit vector along this vector will be, direction is same, 2i plus 3j divided by square root of 13. Now, if you find the magnitude of this vector, 2 by root 13 will be how much? 4 by 13 plus 9 by 13. That will be the magnitude of this vector, and that will be 13 by 13, which will give you 1. Okay, so this will be the unit vector along this vector. Okay, so these questions are very important. If you understand once, it will be very helpful when you go to the next chapter, when you study Newton's second law, where you have to deal with different kinds of forces, and you have to resolve the forces and find the net force. And also, whatever you will study in physics, everywhere you have to deal with vectors, and you have to learn how, once you learn how to resolve these vectors and find the magnitude, direction, then it becomes very easy. Okay.